Welcome, students. After learning about relations, it's time to understand a very important mathematical idea, the function. In simple terms, a function is a special kind of relation between two sets where each element of the first set, called the domain, is related to exactly one element of the second set, called the codomain. Let's recall, a relation from set x to y is just a subset of the Cartesian product x into y. But a function is more strict. It's a relation with an extra rule. Every input must give one and only one output. That means no input in x is left out. No input gives two or more outputs. Not a function. R equals the set 1, 2 and set 1, 3 because the same input 1 is mapped to two outputs. Valid function. F equals the set 1, 2, set 2, 4 and set 3, 6 each input maps to a unique output. So, we can say that all functions are relations, but not all relations are functions. You can represent a function in many ways. Arrow diagrams draw arrows from inputs to their outputs. Set of ordered pairs, like x, function of x, algebraic rule, like function of x equal to 2x or function of x equal to x squared. Here's an example. Let f from n to n defined by function of x equal to 2x where n is the set of natural numbers. Let's understand the important parts of a function. Domain, the set of all possible input values, usually x. Codomain, the set where output values can come from, usually y. Range, the set of all actual outputs function of x produced by the function. Let f from a to n be defined as function of x is roll number of student x, where a is the set of 50 students in a class. Each student, input, has one roll number, output. So f is a function. Domain is set of students. A codomain is set of natural numbers and range is set 1, 2, up to 50. Since only roll numbers up to 50 are used here, f is 1 into 1, no duplicate roll numbers, but not onto, since numbers like 51 are not mapped. We'll dive deeper into types like 1-win and onto in the next video. Functions aren't just limited to whole numbers, they can be defined over real numbers too. And guess what? You already know many such functions. Like this one, f of x equals x squared, that's the square function. Or f of x equals modulus of x, that's the absolute value function. Then there's f of x equals the greatest integer less than or equal to x and f of x equals 1 by x, the reciprocal function, but remember, it's not defined when x is 0. Now, every function has three key parts, its domain, codomain, and range. Take f of x equals x squared, for example. Here, the domain is all real numbers. But the range? Well, since squares can never be negative, the output will only be 0 or positive real numbers. That's why the range is not the full set of real numbers. So always remember, knowing the range tells you what outputs are actually possible, not just what you expect from the codomain. Let's do a quick test. Tell me, is this a function? F equals the set 1, 2, set 2, 4, set 3, 5 and set 1, 3 something's off, right? Yes. This is not a function. Why? Because the input 1 is trying to map to two different outputs, 2 and 3. And that breaks the golden rule of functions. Each input must map to exactly one output. Now, let's fix it. Try this instead. F equals set 1, 2, set 2, 4, set 3, 6. Now this is a valid function, clean and consistent. One input, one output, that's the function way. To summarize, a function is a special type of relation where each input from the domain is associated with exactly one output in the codomain. It ensures no input is left unmapped and no input maps to more than one output. Key components of a function: domain, all possible inputs; codomain, the set where outputs may lie; range, the set of actual outputs generated functions can be represented through arrow diagrams, ordered pairs, algebraic expressions,